In Java, there are a number of wrapper classes as part of their API. These wrapper classes are used to wrap primitive data types, such as integer, int, long, float, double, short, byte, etc. These wrapper classes allow these primitives to be used in contexts that require objects such as collections, list, array list, hash maps, or when using generics. Wrapper classes allow for additional behaviors and properties on top of primitives. These classes also allow you to work with these primitive values in situations where objects are required, such as when using collections or generics, or when interfacing with APIs that expect objects. We'll look at a few of these, namely integers, double, and explore their interoperabilities, namely converting integer primitives to double and vice versa. Integer is much smaller size-wise than double. So when you do conversions from one to the other, sometimes you may lose precisions. The instances of all object classes are immutable. This is a very important concept. This means the internal values or their primitive values cannot be changed once objects are created. This is encapsulation. Wrapper classes are basically abstractions of these primitives, providing some external methods for you to effectuate some changes, but we don't know the internal values or their computations, aside from when objects are created. Namely, if you create an integer wrapper class with a value of 0, then we know that integer value is 0 sitting inside of this wrapper class integer. Wrapper classes start with capital letter, whereas primitive is int, I, small letter I. The wrapper class integer starts with capital I. Let's look at specific examples of integers and double wrapper classes. This is your Java API for both JavaLane.integer and JavaLane.double wrapper classes. The private data and also their accessor, their max value, minimum value for integer, max values and minimum values for double, constructors for integer, constructors for doubles. These are public methods. Their short value, their integer value, their long value, etc. There's conversion going on inside these public methods. Java abstraction encapsulates these implementation details. So is the value being encapsulated. We can also insert string numerics, such as 1, and make use of the integer values of method to convert it into an integer object. This integer object will spit out its integer value, 1, by dotting its integer value methods. There's also parser methods for integer as well as doubled. Both integer and doubles pretty much share similar or mirrored set of behaviors. Let's look at some of the examples. In both integer and double class, we have a set of constructors, a set of class constants indicating max values and minimum values. What's inside these wrapper classes are both integers and doubles respectively. Integer is 4 bytes, which is 32 bits on contemporary computing machines. This means the integer value, primitive, can hold up to 2 to the 32 combination of numbers. That's a lot of numbers you can fit into. The max value is the maximum number that you can store on this integer axis. Minimum is the lowest number you can store inside of this. Because integer are signed, meaning they can be positive or negative. There's also a 0 in the middle. It's safe to say that this minimum is 2 to the 32 divided by 2. Whereas max is 2 to the 32 divided by 2 minus 1. The reason why we have minus 1 is because of that 0 in the middle, which is neutral. Same thing with double, except double is twice the size of your integer, typically 8 bytes or 64 bits. This means there's 2 to the 64, which is a really large number that will yield much larger max value and much smaller minimum values than your integer wrapper class. There's also conversion methods that we saw that allows you to convert string into integer, string into doubles, etc. Let's look at more examples. It turns out that you can instantiate your object. Instantiation means create. This means setting aside heap memory space by inserting a default value that goes into this object creation. You can also insert string. Obviously, this string must be an integer string, like 99 string. If you put alphanumeric and some other characters as string, this will throw an exception in this integer wrapper. Same thing with double values as well. When you construct an instance of these doubles, you got to make sure that your initial inputs, either double value or string s, these must be of double. This means that this string cannot be question mark or pound. It must be something of double type, even though this is of type string to begin with, like 2.3. Let's move on to the next. We talked about minimum and maximum values. They basically represent the maximum value of the corresponding primitive type for max val, and minimum val will be on the other. These are static numeric constants. They do not change. In fact, they are static final as declared inside these wrapper classes. You'll have the same for bytes, short, integer, long, etc. because these are all primitives and they all have the maximum value and minimum value that they can hold when instantiated. Therefore, you don't want to pump a value into an integer, for example, that is much greater than max value because your computer is not going to be able to support its storage, let alone computing it. Therefore, when you make use of these integer or integral wrapper classes, sometimes you may have to check to confirm that the inputs from external client making use of this wrapper class does not exceed the max value or go lower than the minimum value that this class primitive supports. We already talked about these bits and bytes. For reference, they represent these very, very large numbers and very small numbers for max and min, respectively. Let's move on. Let's talk about conversion methods. Wrapping these primitive values inside the wrapper class means that sometimes you may need to fetch their primitive values. So they are double value, float value, notice the capital V. These are the behavior names that you can specify to fetch the primitive. These methods basically convert objects into primitive types values. Imagine that you have a wrapper class, let's say integer. Inside this integer, there is a in, 1, 2, 3. These conversion methods basically allows you to convert your wrapper object into a straightaway primitive value, 1, 2, 3, via in value. This is where interoperability happens. Whereas you can use these numbers to instantiate an instance of an integer, you can also use int value to fetch its internal primitive value. Same thing with short, long, double. Let's move on. Let's talk about static value of. This is wrapping and unwrapping the integer class examples, providing methods to convert between integer and integer, primitive to integer object, double primitive to double object. Same thing with long, short, etc. The way that you do it is because this is static, which is of the class, not of the instance. You can use the double class name, dot value of, making sure that this is exactly what you want to convert into object-wise to construct and fetch this double object. This value of creates a new object. There's a lot of implementation details being hidden, but this dynamically creates an object of double with that value 12.4 inside of it. Same thing with this integer value of 12, which dynamically creates a new integer object with the value of 12 sitting inside of it. And that object reference is called integer object. These are very costly operations because whenever you create new objects, that carves out a memory inside a heap, and there's initialization that happens as part of the object construction. And then you have the assignment of that object into this reference. This all happens in one line of code. Again, what we're illustrating here is the concept of both abstractions and encapsulations in object-oriented programming. Beyond these conversion methods and creation methods, there's also methods for arithmetic operations or conversion to and from strings and comparisons, such as parse in. You can read up on these APIs in Java, which also includes toString. These takes strings and integer respectively. They have different implementations that you can make use of to solve your computing problems. This shall complete our discussions on integer and double wrapper class examples.